When I came to UNI, I just knew that I liked science, hence the double major, hence the indecision bouncing between departments. But since then, I've been exposed to so many interesting applications and opportunities. I mean, through my summer experiences, everything was just showing you the different possibilities of what you can do with a science degree. So I can absolutely say that I know about possibilities now that I never dreamed of coming out of high school.
I think it's given me a better picture of where I want to go. I wasn't really sure what type of chemistry I was interested in. I hadn't picked kind of a route, but I think that this has helped show me that I really am interested in analytical chemistry.
So it's called instrumental analysis. We're learning how the instruments work, but then every lab period we go and we get experience on a different one that's actually in the lab. And so it's been really fun to be hands-on. There's a lot of emphasis on the kind of engineering aspect, like we've built a few of our own instruments out of Legos, because if you can have fun while doing science, why shouldn't you?
The museum has hundreds of thousands of artifacts stored in their cabinets. Some of them are real, some of them are authentic, some of them are in good condition, some of them are in bad condition. And they, quite frankly, don't have the resources to know which artifacts are authentic, which are fake, which are even worth keeping. 2 years ago, when we started the research project, the first question was what was used to preserve the tusk? And we found a bunch of heavy metals, lead, arsenic, and a few other things. And that first initial test immediately told the museum, we need to treat this in a special way in order to start cleaning it up so nobody gets hurt. So it's providing them the ability that they don't have to go out of the university, they don't have to ask for budget resources.
I knew that I would be able to do some research, and I wasn't quite sure on what I would be doing, but I didn't realize how such like a historically important aspect in like an archaeological standpoint would influence me, I guess, in where I wanted to go and what I wanted to do.
It felt very important because this is going into real work, and people with jobs are going to use this hopefully in the future and be able to use it to help preserve a very important artifact from Iowa. So it definitely made me feel like I needed to understand better what I was doing and what each thing I did had and how it affected the rest of the project.
My project itself with the near-IR mapping is actually set up in a way that future classes and future students can build off of what I've done.
So a lot of this is aimed at the idea of either being a laboratory scientist where somebody gives you the problem to solve and you don't necessarily have the full procedure right in front of you. You need to come up with a way to benchmark the different tests, get the information somebody wants. Another chain where this could be heading is into students going into full-time research careers where their life might hinge whether or not they can get that next research grant written and funded and so forth.
When you get out into grad school or a real working job, you're doing a lot of research and then having to analyze your results. So this allowed us to be very independent and kind of come up with our own research that we wanted to do and work on proposals and kind of go through that whole process.
Don't be afraid to be interdisciplinary in college. I know physics and biochemistry don't seem like they have a lot to do with each other, but after my first research experience in a biophysics lab, I soon learned that nothing could be further from the truth, and it's always exciting to be able to mix disciplines.